All right, guys. So I cut down these videos a little bit to focus on the objective. The most important parts are balanced and unbalanced forces, being able to tell the difference between balanced and unbalanced forces, as well as naming the four different types of forces. So in your project this week, I want you to show me the difference between unbalanced and balanced forces, as well as applying the four different forces to an everyday situation in your life. So most importantly, what is a force? The force is a push or pull action that can make things move, change direction, or change shape. So as you go around your house, find something that you can push or pull, make it move, make it change direction, or make it change shape, and tell me what forces are being applied and whether that, and show me how you distinguish between a balanced and an unbalanced force. So how can you show this in a drawing or in a video? You can show me by demonstrating their vector arrows. A vector arrow is simply an arrow that shows the direction of the force as well as the strength of the force. The longer the arrow, the stronger the force. And the direction of the arrow tells me the direction of the force. So these two arrows both moving to the right, but obviously the Lamborghini, the supercar Lamborghini, has a longer arrow because it has a larger force. The little girl's toy car has a smaller force, so it has a smaller arrow. A really important concept is that forces always act in pairs. When you've got one force moving in one direction, there is always a force acting in the opposite direction. Always. Forces are never by themselves. If you have a football player pushing on a sled, there is always a force acting in the opposite direction. That's what's making the football player work so hard. So the football player is applying a force to the sled, and the sled is pushing back against the football player because of friction. Forces are measured in quantities of newtons. We calculate that using force equals mass times acceleration. Simple formula. That means that the greater the mass, the greater the force. The greater the acceleration, the greater the force. If you calculate and multiply mass times acceleration, you can calculate your force. So if we increase the force of this apple, if we increase the mass, of this apple, then we will increase the force. The mass of the apple falling on Newton's head times its acceleration equals its force. But if I increase the mass to the mass of this anvil, then it will have much more force falling on Newton. The force of a Ferrari parked is much less than the force of a Ferrari accelerating. Think about Ferrari moving. It's got a lot more force if it were to hit something than a Ferrari that is parked. So you can increase the force by increasing its mass and or its acceleration. The difference between balanced and unbalanced forces. So unbalanced forces are when things are moving. So if things are unbalanced, that means that the direction of the forces or the arrows of the forces are not the same. They are not equal. One force is stronger than the other. You can see that by the vector arrows in this video. The force of the train is much greater than the force of the truck, and so therefore the train moves the truck. So if something moves, it is because the forces are unbalanced. So unbalanced forces make things move. The force pairs are not equal, and one arrow is greater than the other, and therefore something is moving. If an object is not moving, like these rocks balanced here, that means the forces are balanced. That means that the arrows and the forces are equal, and there is no acceleration. So the arrows here are equal in shape, they're equal in length, but they're moving in opposite directions. They're pushing against each other, so there is no acceleration. So if equal forces move in opposite directions, you have a balanced force. Here are four different forces that we will be talking about. Forces work on everything. Here are four of them. Gravity is a force that pulls objects towards each other. Since the mass of Earth is so big, it pulls you towards it. So gravity pulls you towards Earth. Normal force pushes back up against it. Normal force works with gravity. So if you got gravity pulling down, then normal force pushes back up. That is its force pair. So gravity's pulling this book down. Normal force is pushing it back up. Gravity pulls these rocks down, but normal force pushes it back up. Applied force is really simple. It is when you apply a force to an object. So anytime a force is an object you are pushing or